Welcome back for another deep dive. This time we're looking at something pretty cool, I think, AI video editing.
Oh, yeah. Definitely a hot topic.
It is, and this paper in particular, ReVideo, remake a video with motion and content control, is really pushing the boundaries of what's possible.
It is, yeah. And it's interesting to see how they're tackling this challenge of controlling both the content, like what's actually in the video, and also the movement, how things are moving.
Yeah, that's one of the things that really struck me when I was reading the paper. Um, just looking at Figure 1,
Yeah.
some of the examples they show are pretty mind-blowing. Like they can actually swap out a static object in a video for one that's moving.
Right. And not just like a simple swap. It's like they can seamlessly blend it with the original footage. So you have like a parked car, and then all of a sudden it's driving down a winding road, and it just looks completely natural.
Yeah, it's incredible. But I mean, I can already imagine the technical hurdles involved in pulling something like that off. Like, how do you modify one part of a video while keeping the rest intact and still making it look realistic?
Yeah, that's the real challenge, and it's something that previous approaches to AI video editing have struggled with. Some of the earlier methods, they relied on text prompts, which could be kind of hit or miss.
Yeah, you're basically just crossing your fingers and hoping the AI understands what you want.
Exactly, and then you have other methods that focused on broader style transfers, which could be cool, but they lacked that precision you need for really targeted modifications.
So you're saying those older methods couldn't really handle the fine-grained control that ReVideo offers?
Right, they just weren't there yet. You know, there were some newer techniques that allowed for more specific object modifications, but they still couldn't do things like realistically add a new object to a video or control its movement in a really precise way.
And I'm guessing that motion editing, that an ability to control how things move, is crucial for making those edits look believable.
Absolutely. I mean, if you just add a new object and it's just sitting there static, it's going to look super fake, right?
It's going to stick out like a sore thumb.
Totally.
Yeah.
So ReVideo takes a different approach. They're leveraging the power of stable video diffusion, or SVD, which is a really sophisticated model for video generation, but they're adding these specialized control modules on top of it that let the user dictate both the content changes and how that new content moves within the scene.
Okay, so they're building on existing AI technology, but adding this whole new layer of user control.
Hmm.
That's pretty cool. Can you give me an example of how that works in practice?
Yes. So imagine you want to add a dog running across a soccer field in a video. With ReVideo, you would start by modifying the first frame of the video, inserting the dog where you want it. And then you would draw a trajectory line right on the video showing the path you want the dog to take.
Wait, hold on. You just draw a line to show how you want the dog to move?
Mm.
That's it. That seems incredibly intuitive.
It is, and that's one of the things that makes ReVideo so innovative. The model then takes that trajectory information along with the user's modifications to the first frame and uses it to generate the rest of the video, seamlessly integrating that dog into the scene.
So it's almost like giving the AI a set of instructions like, put the dog here and make it run along this path.
Exactly. But even with this really innovative approach, there are some major challenges involved in getting the unmodified content and the new motion-controlled content to work together in a way that looks realistic.
Yeah, I can imagine it's like trying to get two very different things to play nicely together.
That's a great way to put it. One challenge is what the researchers call training imbalance. Basically, the model has to learn from two very different types of input. You have the unmodified content, which is visually rich and dense, and then you have these kind of sparse, abstract motion trajectories that the user draws.
So it's like trying to teach someone to cook using a detailed recipe book alongside a handful of scribbled notes on a napkin.
That's a perfect analogy, and it can really throw off the training process if you're not careful. The other issue is what's called condition coupling. Because the unmodified content naturally contains motion information between frames, the model can end up relying on that existing motion and basically ignoring the user-specified motion trajectories.
So how do you get the model to actually pay attention to those trajectory lines and not just follow the existing flow of the video? Like, how do you make sure it's actually incorporating the user's input?
Well, that's where ReVideo's three-stage training strategy comes in.
Okay, this is where it gets really interesting. Lay on me. What are these three stages?
So the first stage is called motion prior training, and it focuses specifically on training the motion control module independently of the content control module.
So it's like giving the model a crash course in understanding motion trajectories before you throw in all the complexities of the content modifications.
Precisely. This helps the model develop a strong foundation for interpreting those motion trajectories, so it's less likely to be swayed by the existing motion in the unmodified content. Then comes stage 2, which they call decoupling training. And this is where things get really clever. To prevent the model from over-relying on that existing motion in the unmodified content, they actually take the modified and unmodified parts of the video from two completely different videos during training.
Oh, interesting. So instead of using one video where you're adding a dog to a soccer scene, you might take the soccer scene from one video and the dog from a completely different video.
Yeah, exactly. And by doing this, you force the model to rely on the user-specified motion trajectories because it can't cheat and just follow the pre-existing motion from the unmodified content. It's like saying to the model, okay, you can't just copy the motion from the soccer video. You actually have to learn how to move this dog based on the trajectory I've given you.
That's a really clever way to address that condition coupling problem. It's like teaching someone to dance by showing them the steps in isolation before you have them try to dance with a partner.
Exactly. And then finally, you have stage 3, which is called deblocking training. And this stage focuses on removing any kind of blocky artifacts that might appear at the boundaries between the modified and unmodified content.
So it's like a final polish to make sure everything blends together smoothly and naturally.
Exactly. Now, you mentioned earlier the spatiotemporal adaptive fusion module. What exactly is that, and why is it important for ReVideo?
Yeah, tell me more about that.
So this module, which they call SAM, is kind of like a smart mixer. It dynamically blends the influence of the unmodified content and those motion trajectories throughout the entire video generation process.
So it's like having a conductor who's constantly adjusting the volume of the different instruments in an orchestra to create a harmonious sound.
Yeah, that's a great analogy. It ensures that the right information is being emphasized at the right moment as the new video is being created. So it helps the model decide when to prioritize the user's modifications and when to kind of stick with the original content.
Gotcha. So SAFM is playing a crucial role in achieving that seamless blend between the edited and unedited parts of the video. What about the results? Did ReVideo actually live up to the hype? What kind of performance were they able to achieve?
Yeah, so the results are really compelling. They found that ReVideo consistently outperforms existing methods in terms of accuracy and user control, especially when it comes to those trickier tasks like adding new objects and controlling their motion.
Do you have any specific examples from the paper that really highlight ReVideo's capabilities?
Sure. So, for example, the paper shows how ReVideo was significantly better at adding a moving object to a scene, like they were able to achieve a 20% improvement in accuracy compared to previous methods. And they also demonstrated its effectiveness in tasks like changing the motion of an existing object, like making a car drive along a curved path instead of a straight one.
So they really put ReVideo through its paces and showed that it can handle a variety of these really challenging editing tasks. But even with all these incredible advances, the paper does mention some limitations and areas for future work. Can you tell us a little bit more about that?
Yeah, for sure. One limitation is that ReVideo's success is somewhat dependent on the capabilities of that base SVD model. If SVD struggles to generate realistic content for a particular type of scene, then ReVideo is going to inherit those limitations.
So as the base model gets better, ReVideo's capabilities will also expand.
Exactly, and the researchers acknowledge this in the paper. They suggest that future work could focus on improving the base model's generation capabilities, especially for those more challenging scenes. So this could involve things like training SVD on more diverse data sets or developing new techniques to handle complex motion and object interactions. Another area for improvement is the way that users specify motion. Right now, it's based on these fairly simple trajectory lines, which might not be sufficient for very nuanced or complex movements.
Yeah, I can see how that could be limiting. I mean, drawing a simple line might work for basic movements, but what if you want something more intricate, like a dancer performing a complex routine or a gymnast doing a flip?
Exactly. Future research could explore more sophisticated ways to input that motion information, perhaps incorporating things like 3D models or skeletal animation or even motion capture data. This would allow users to control the movement of objects in a much more detailed and realistic way.
Yeah, and it's interesting too because the researchers, they point out some really specific limitations. Like, for example, they say that the model sometimes struggles when the scene being edited contains a lot of repetitive textures or patterns.
That makes sense.
Mhm.
Like if you're trying to edit a video of a forest or a field of grass, the model might have a hard time distinguishing between the individual elements, and that could lead to some weird artifacts or distortions.
Exactly. And they also mentioned that the model's performance can vary depending on the resolution of the video.
Oh, so a higher resolution video might actually be harder to edit because there's just more data for the model to process. Right. And all of these limitations, they kind of point to areas where future research could really make a big impact. Like they talk about the need for more robust models that can handle a wider range of scenes and video resolutions.
Yeah, and I imagine as the underlying technology continues to improve, we'll see even more sophisticated and versatile video editing tools emerge.
Absolutely.
Yeah,
It's an exciting time to be working in this field, that's for sure.
it really is. Well, this deep dive has definitely given me a lot to think about. From the technical innovations to the ethical considerations, ReVideo represents a major leap forward in the world of video editing. It's exciting and a little bit daunting to imagine how this technology might reshape our visual landscape in the years to come.
I agree. It's a powerful tool that has the potential to change the way we create and consume video content. But as they say, with great power comes great responsibility. It's up to us to ensure that these advancements are used ethically and for the benefit of society as a whole.
Absolutely, well said. Well, on that note, I want to thank you for joining me on this deep dive into the fascinating world of ReVideo.
The pleasure was all mine.
And to our listeners, we'd love to hear your thoughts on this groundbreaking technology. What are your hopes and concerns about the future of AI-powered video editing? Share your insights and join the conversation. Until next time, keep diving deep.